Hi, thank you for watching our video. Today, we will be talking about true experimental designs and quasi-experimental and longitudinal designs. My name is Paige Snell, and Ashley Bauman will be joining us shortly in our discussion of these topics. But as we start, we both feel it's important to note the themes of wisdom throughout literature and scripture. In scripture, wisdom is celebrated as a treasure that is worth seeking. According to Proverbs 3:15 through 18, it is better than riches. It's a source, God is the source of all wisdom, who alone he is perfectly wise. We also find that Jesus was an example of wisdom in his actions and attitude. And in Colossians 2:3, it says, Jesus is in whom all wisdom is found. And Jesus even used wisdom when he was tempted in the desert by Satan and utilized wisdom in order to combat the hard and trying tempting times. In other words, a truly wise person tries to seek life from God's point of view and chooses to live according to God's wisdom. As we do research and as we're experimenting, we are doing some of the same thing. We are looking to understand truth and wisdom through other points of view by manipulating different variables and different treatment options, so that we can understand more about our field that we're passionate about. But more importantly, as we are working through our world lens of Christianity and looking to seek wisdom in our field, the first step is to be seeking God's wisdom. So as we start this journey, we're going to start by talking about true experimental designs. The emphasis of a true experimental design is to have a lot of experimental control and to minimize your extraneous variables through random assignment and manipulating your independent variable. How you know something is really a true experimental design is that there is random assignment of people to control in treatment groups. There are a couple different types of experimental designs we will be looking at today, of true experimental designs. We're going to start with the between group, which means that you're comparing variables across two or more groups in really controlled experimental conditions. So for example, one group receives treatment and the other group does not in your experiment. We're also going to be looking at within subjects designs, which is an attempt to minimize error variance by having each participant serve as their own control. All participants are exposed to the same treatment, but maybe in differing orders, frequency, duration, etc. So some pros and cons of the different types of between groups designs. Overall, between groups designs are great because there's a high level of internal validity. But some cons are that it's really hard to generalize to other populations or generalize to settings that are not an experimental setting. Because in any of those settings, you lose your ability to control for all the extraneous variables, which is very important in a true experimental design. Also, in a true experimental design, doing the between groups designs, you're withholding a study treatment for your control group or waitlist group, which can bring some ethical concerns. In doing a post-test only design, the advantages are that it's really cost efficient. You are able to conduct your experiment and only utilize one instrument, one test, which also means it can take less time. But it also eliminates pretest sensitization, which is the phenomenon that happens when your participants are exposed to a pretest and are able to extrapolate what you are trying to study and what you are trying to understand without being told, like through the questions on the pretest. However, some cons of the post-test only design include that you just get limited information on group equivalents prior to treatment. So you don't know how your experimental group and control group compare before the treatment because you don't know, you did not give them that pretest. So in a pretest, post-test design, some advantages are that your pre-scores are controlled for and help you select and remove cases, and also describes your participants easier. So for example, if you're doing a study on levels of depression and as you administer your pretest, you notice that a few people in your treatment group don't even test for levels of depression. You could wean that out early on so that they would not become a confounding variable in your experiment. And then you can also use the pre-test and post-test scores to examine individual performances as well as the group performances. However, your biggest risk associated with pre- and post-test design is the sensitization due to the pre-test. So this is a simple between groups post-test only design with one control group. So you start with a population, a sample out of a population, and they are randomly assigned to their treatment group or control group. After they're randomly assigned, the treatment group is given the treatment, and then they are observed via the post-test to see how treatment affected them. The control group is given nothing, and then they're given the post-test. Now, some problems with control groups in general is that it is unethical to withhold treatment from those who need it when you already know a treatment is working or is proven, is an evidence-based practice. So some options include you could put your control group on a wait list, and so that way after your experiment, they are given the same treatment that your experimental group received. You could also do a placebo control group in which participants believe they're receiving a treatment, and then afterwards they are given the treatment that the other group receives. Or a matched control group where participants are paired with others in the treatment group. So in this design, we're looking at a pre-test and post-test design. So again, you have your sample and they're randomly put into two groups, the treatment group or a control group. In this design, however, they are given the pre-test or observed early on. So that is 1A for the treatment and 1 control. And then they are either given the treatment or they are the control. And then you are administering a post-test to get your observations of how treatment worked, did not work, affected them versus how change occurred in the control group. So another type of between groups design is a factorial design. A factorial design is used when 2 or more independent variables are employed simultaneously to study their independent and interactive effects on the dependent variable. For example, if you were doing a study to measure the effectiveness of 2 different interventions designed to enhance cross-cultural awareness in students based on gender, you would have a 2x3 factorial design, as in the top of our slide. You would have 2 different groups, the dependent variables or gender, and then 3 different treatment options, either treatment 1, treatment 2, or control. An advantage of this is that you can see how a treatment operates on a deeper level. So you're breaking down the effects of your independent variable into maybe different demographics such as personality type, intelligence level, or even gender. A limitation is that it's complex and pretty expensive to conduct this research. So now we're looking at a dependent samples design. In this design, you address the issues that may happen with random assignment of participants to groups because it matches comparable groups based upon a variable. So for example, if you were measuring, if you were looking to measure something and intelligence was a variable that was a part of that, you would administer, that would be an independent variable, and you would be able to pair people with similar IQs to different groups in order to look specifically at the way intelligence also affects your treatment or control, if it does. So next we're going to move on to within subjects design, and a really big strength of within subjects design is that there's no control group needed. Each participant serves as his or her own control. So they're randomly assigned to treatment groups, and all participants are exposed to treatment conditions. The randomization involves randomly assigning them to different order or frequency or duration of the treatments. So in our example here, you have a sample that is observed in the beginning. They are administered their treatment or their independent variable. They're observed again, and then they're administered the second one. So whether or not that's a control or a different treatment before being observed again. They are usually crossed over in the middle of the treatment. But there are a few threats to internal validity, including history, which means that events might have happened between administration of the two treatments. Maturation, some people just change over time, and that could account for the differences in pre and post test. Order effects, it could be that a treatment is more effective when administered in order A instead of order B. So you may not have a strong inclination of results. In sequence effects, it could be that some treatments work better when following others. So those are some threats to our internal validity when using this crossover design. In a counterbalanced crossover design, you control the sequential order to eliminate threats to internal validity to balance it out amongst your two groups. So participants are randomly assigned to the two groups that differ in the order in which they receive treatment. So as you see here, participants are randomly assigned. They are observed. The group on top is administered treatment 1 before their second observation, and then they receive treatment 2 before their third observation. However, group 2 is observed and then administered treatment 2 first, observed, and then treatment 1. This now allows a researcher to tell if the order of the treatment makes a difference and if it causes a change in participants over time. And now each group, the order effects are controlled for or equal in both of the treatments. So some strengths and limitations of our within subject design. You definitely have a lot of experimental control and high levels of internal validity and low error variance. You also can use fewer participants as between subjects because each participant is serving as their own control group. You therefore eliminate some cost, some time in acquiring participants. However, you do lose time because it takes longer to conduct than a between subjects design. Since you're having to compare each person or each group to themselves, you are essentially going to have to double, depending on your number of independent variables, how long the experiment takes. Also, there are some order effects that are threats to internal validity. And so you need to allow for different order or sequencing in order to eliminate that threat. And then you're restricted on the variables you can do. You know, your two treatments could be incompatible, or the combination of treatments you choose could not be as effective as you thought they would be, and therefore you would have to, go back, start again, or even choose different treatments, which could add to time and cost of your experiment. And with that, Ashley's going to lead us on our quasi-experimental journey.
Yes, so now we're going to look at quasi-experimental and longitudinal designs. So with true experimental, it's great for internal validity and controlling and eliminating threats. Random assignment, like Paige said, is the hallmark. But much of counseling research happens in natural field settings, which limits the amount of control researchers can have on the design. So random assignment's not always possible. So when that happens, we can use quasi-experimental design because it offers more flexibility. Like true experimental, quasi-experimental manipulates one or more independent variables, but there's no random assignment. So researchers have a little bit less control with quasi-experimental than true experimental, but there are many benefits. So the two major classes of quasi-experimental designs that we're going to be looking at are non-equivalent group designs and time series. So why choose quasi-experimental design? Well, first we're going to look at cost. True experimental can be expensive with time and resources, but quasi is typically inexpensive of time and resources. And you can evaluate people in naturally occurring settings such as classrooms, treatment facilities, and therapy groups. There are some selection issues to consider. With true experimental design, ideally the recruited pools of participants are randomly assigned to treatment or control groups, but that's not always feasible with your participants for factors such as scheduling. So quasi-experimental sometimes is more appropriate to use pre-existing groups because it also enhances generalizability of your design. However, the limitation is that you have to keep in mind that these pre-existing groups were formed for a purpose other than our research. Ethical consideration is allowing pre-existing groups decreases chances of people waiting for treatment when they're in need. And then the last is unavailability of control groups. So time series allows for inferences by comparing observations over time. So in this, the researcher can infer whether the intervention or treatment had an effect by comparing observations before or after an intervention. So we're going to start by looking at non-equivalent group designs. So comparisons and these non-equivalent group designs are made between or among participant and non-randomly formed groups. They're non-equivalent because the participants were assigned to a group prior to the research being done, and they may differ on several characteristics. So the two types we're going to be looking at are uninterpretable non-equivalent and interpretable. So for the uninterpretable non-equivalent, these are uninterpretable because there are multiple threats to internal validity. So you're going to see multiple diagrams listed. And so when you see non-R, what that stands for is non-random assignment. The X is the independent variable or treatment, and the O is the observation. So for this one group post-test only design, you see that an observation is made on the dependent variable after treatment. It's impossible to interpret with this because there's no way to infer any type of change had actually taken place because there was no observation in the beginning. So no control equals that it's impossible to investigate for maturational or historical processes. Over post-test only non-equivalent design, these are two different types of post-test only non-equivalent design. In the group on the right, one is compared to a control group, but you don't necessarily need a control group for this type of design. And the one on the left. And then the one on the right, you have two or more treatments that are being compared. That is allowed. And so that is demonstrating that there's multiple treatments being compared in this type of post-test only non-equivalent. So with this type of design, the post-test is weak because it's difficult, again, to attribute results to the actual treatment. The lack of information about the differences within the groups before treatment makes it hard to conclude what treatment actually did for these groups. Next, we have one group pre-test, post-test only design. And this is stronger than one group post-test only because you actually have something to compare it to. So we can determine if change occurred because we observed before treatment and after treatment. But it's possible the cause of treatment is still ambiguous. So what this means is there are other variables that we might not be accounting for, such as history, which is events happening between pre-test and post-test that may also be contributing to change, maturational processes. And then, so you actually need a comparison group to rule out threats for internal validity. So next, we're going to shift over to interpretable non-equivalent designs. And so for this, we're going to start with the pre-test, post-test design. So with this, participants in both groups are non-randomly assigned, and they're both given a pre-test on the dependent variable. So one group receives treatment while the other doesn't. And so the strength of this design is that it allows for examination of pre-treatment, but it's important to note that O1 and O3 are not necessarily equal, but that they're close enough. And that needs to be stated in the design, that these are not equal, but they are close. The next design we're going to look at is the proxy pretest measure. So for this, researchers may not want to or may not be able to pretest participants in the groups. So if they're worried about things like pretest sensitization, they can use the proxy pretest, which is a similar test to the post-test, but it's not an identical test. And this helps with your sensitization for your participants. So A and B represent two forms of a test, and you have non-randomly assigned groups. So the proxy pretest is administered in OA, and then to both groups, and then one group gets the treatment, and then both groups are then retested with symbol OB. The next is the pretest, post-test non-equivalent with an additional pretest. So for this, sometimes a pretest can strengthen a design. So the second pretest enhances the interpretability of the design. The major threat to internal validity involves a selection by maturation interaction. So in other words, participants from the two groups might be maturing at different rates because of some selection characteristic. And then the final group we're going to look at for the interpretable non-equivalent designs is the reverse treatment pretest post-test. So this is actually rarely used in counseling research, and part of that is because there's an ethical dilemma here. X plus is a treatment that's expected to influence the post-test in one direction, while X minus is a treatment expected to influence in another direction. So the ethical dilemma here is that if we are looking at the effects of anxiety and we're giving a treatment to either one, we might be giving a treatment to enhance anxiety, and the other would be to diminish anxiety. That's an ethical dilemma for us as counselors, because we are ethically obligated to do no harm, and helping people to increase their anxiety is a harmful behavior. The next is we're moving into cohort designs. So cohort designs are non-equivalent group designs that utilize adjacent cohort groups that share similar environments. So an example of this is a 6th grade class in a particular school year, and it's being compared to the next 6th grade class the following year. Those are cohort designs, and they're likely similar because they're in the same school. So the advantage is the cohorts are more likely to be similar to each other than other non-equivalent groups. So we're going to start with the post-test only cohort design. And you're going to see the broken line indicates the two groups are successive in their cohorts and not non-equivalent groups. So O1 post-test is administered to the first cohort, and down below you see the O2, the same post-test, is administered to the second cohort after the treatment. So testing occurs at different times because the cohorts follow each other through the system. However, post-testing occurs at similar points in the cohort's progression. So the next, we're going to look at post-test only cohort designed with partitioned treatment. So here you see that O1 is the first post-test given to the first cohort. X1 and X2 are different levels of treatment. So O2 is the post-test given to all members of the same cohort regardless of the level of treatment. So in this post-test only cohort designed, they can be strengthened by the partitioning of treatment, which involves giving differing amounts of treatment to differing groups. So X1 and X2 may have been different amounts of treatment, which is going to affect your O2. The next is your pre-treatment, post-treatment cohort design. So here, this is the first cohort is pre-tested O1 and then is post-tested in O2. The second cohort is pre-tested, and you see that in O3. They're treated with X and then they're post-tested O4. The advantage of this pre-test asserts that two cohorts were similar prior to treatment. And the disadvantage of this is that the pretest threatens external validity and sensitization. Remember, whenever there's a pretest, you are at risk for pretest sensitization. So our final stretch here, we're going to look at time series designs. So time series designs, the defining characteristics is multiple observations over time. So the same participants or similar participants are being viewed over an extended period of time. Treatment is what we consider an interruption in this series. So the logic of this is being able to observe before and after treatment to see what changes have been made. So first, we see a simple interrupted time series. So we have multiple observations before treatment. So O1 through O6, we did 6 observations. We had treatment. Treatment was initiated, and then we observed O7 through O12. And what we're looking for is we're looking for any changes in pre-treatment and to post-treatment. So two advantages of this type of design over other quasi-experimental designs is the researchers can detect maturational changes prior to treatment. And it also allows for an analysis of seasonal changes. So next we have the interrupted time series with a non-equivalent dependent variable. So the main threat to the internal validity of a simple interrupted time series is history. So something other than the treatment is affecting these observations. So to reduce this threat, we're going to add a second group or a second dependent variable. So the OA time series represents one dependent variable, and the OB time series represents another dependent variable. So if OA series shows an interruption at the time of treatment and the OB series does not, then the internal validity of the treatment effect is enhanced. And so finally, we have the designs examining the analysis of contaminants in a time series. So if the researcher is wanting to know more, such as if other changes in one variable in the time series cause a subsequent change in another variable in the series. So in essence, we are measuring for two dependent variables are being observed. So an example of this is, so say we're looking to treat anxiety in this series. Anxiety is the main thing we're measuring for. We may add a second dependent variable of counselor disclosure in this B series. So in the B series, the counselor might be doing more self-disclosure, and it might be predicting the client's level of self-disclosure. So if you want to look at multiple variables, dependent on multiple variables that are affecting the dependent variable, this time series is the way to do it. So thank you for joining us today. We hope that you enjoyed our show. Please subscribe and get home safe.